hello students, welcome you all on Engineers Career Point. So today in this lecture we are going to discuss one of the most important topic, that is sorting. We have various type of sorting. First one is insertion sort, bubble sort, selection sort, merge sort, quick sort, and radix and counting sort, find and heap sort. So in this lecture we are going to discuss one of the important sorting technique, that is insertion sort. Fine. Insertion sort. So what is the input in this case? Input is an array of n element, and what is the output? We want to sort this given array. We want the sorted array. Fine. So how we can use the concept of insertion sort to sort a given array of n element? Suppose we have an array. Suppose the first element in the array is 10. So suppose 10 came. So as array is empty, so we can insert just 10. Now suppose next element is 20. Next element is 20. So already we have element 10, and if we want to insert 20, first of all we have to do the comparison between 10 and 20. Yes, 20 is greater than 10, so just insert it. So can you just tell me, parallelly if we talk about the number of comparisons and number of swap. So for first element, as array is empty, so 0 comparison and 0 swap. But in the second case, when 20 element came, so we have to compare it with 10. So we perform one comparison, but as 20 is greater than 10, so no requirement of any swap operations. In the similar manner, if we have next element is 30, fine, and already input is 10 and 20. So if we want to insert 30, we have to compare 30 and 20. Fine. So 30 is greater than 20, it means no need of swap. So only one comparison, 0 swap. Fine. Now in this case, if we apply the same concept and if we insert the nth element, then again for that one comparison and 0 swap. So now can you just tell me how many number of comparisons we perform in insertion sort? So number of comparison is, if we have n elements, so for first one there is no comparison, but for the remaining n minus 1 element we have one comparisons, but there is no swap in the best case. Fine. So I can say the best case time complexity of insertion sort is how many number of comparisons? N minus 1 comparison, each will take constant amount of time, which is going to be, for best case we have to write the omega, so omega of n, but 0 swap. Fine. If we talk about the worst case behavior of insertion sort, we have to talk about worst case behavior of insertion sort. So I can say, suppose the first element is 50. So as array is empty, so number of comparisons and again the number of swap we have to count it. So for first element, 0 comparison and 0 swap. Suppose the second element is 40. For that we have to compare 40 and 50. As 40 is less than 50, so we require to swap these two elements, so 40 and 50. So we just compare 40 with the 50 and perform one swap. So one comparison, one swap. In the next case, suppose element 30 came. So we have the input 40, 50, and if 30 came, so first we compare 30 and 50. As 30 is smaller than 50, so our intermediate result is 40, 30 and 50. Again we compare 30 and 40 and swap it. So my output is 30, 40 and 50. So how many comparison? One is between 30 and 50, second is between 30 and 40. So two comparisons. And how many swap? One swap is between 30 and 50, next is 30 and 40. So two swap. Fine. In the similar way, if we talk about, like my input is right now, and if the next element will be 20, so we have to compare first 20 and 50. So my intermediate output is, next we have to compare 20 and 40 and swap it, and next again we have to compare 30 and 20 and swap it. Fine. So how many comparisons? 3 comparisons and 3 swap. Fine. In this way, if I talk about the nth element, how many comparisons? N minus 1 comparison and n minus 1 swap. So if we see our total number of comparison is 0, then in next iteration 1, then 2, then 3, then 4, and then n minus 1. So total number of comparisons I have, first one is 0, then 1, then 2, then n minus 1. So, or you can say 1 plus 2 plus n minus 1. This is the sum of first n minus 1 natural numbers. So, if we talk about for n number, it is n plus 1 by 2. For n minus 1, it is n minus 1 into n by 2 number of comparisons. Asymptotically, total number of comparisons are n square. In the similar manner, we have number of swap. How many? Same, that is again big of n square. So time complexity is n square plus m square, that is big of n square only. Fine. So in this way I can say that for insertion sort, best case time complexity n or omega of n, and worst case time complexity is big of n square. Here you have to keep in mind the total number of comparisons and the total number of swap. One question they ask in GATE, what is that? In general, suppose my input is like this: 10, 20, 30, 40 and 50. Suppose one element came, that is 5. So to find out the correct location of 5, what we are doing? We compare 5 with 50, then 5 with 40, then 5 with 30, then 5 with 20, then 5 with 10. It means which type of searching we are using? We are using here linear search. Fine. But they are mentioning that why you can go for linear search, as we know input is sorted. So why not you use binary search? So let's use the binary search and then tell me the time complexity of insertion sort. So in this case, if we go with the binary search to find out the exact location of 5, so this is my array. Fine. Now I want to insert 5. To get the exact location of element 5, what you have to do? Go with the middle element. 5 is less than 30, so apply the binary search in this side on the left hand sub array. Again find out the middle element. In this way, for searching, how much time it will take? For searching the exact location, we require log n time. But the point is, then we know that 5 came here. But now we have to perform the swap operation. It means 10 move here, 20 move here, 30 move here, and 40 move here, and 50 move here. Yes or no? So how many number of swaps? Again n. Swap is order of n. That is for one element. that is for one element. So if we talk about the n element, because they are asking us the total time complexity of insertion sort if we use binary search instead of linear search. So the total time complexity is, so total number of searching time is n log n, because for one element it will take log n, for n log n, plus total number of swap for one element n, for n element it is n square. So again we make a conclusion that still it will take n square time asymptotically, but yes, we reduce some number of comparisons. So my dear students, in insertion sort, best case omega of n, worst case big O of n square, and if we use binary search instead of linear search, then again my time complexity will be n square. So you may face many problems which are totally based on insertion sort. So keep practicing, and if you are a student from third year, final year or second year, and if you want to prepare for GATE 2024 or 2025, then Engineers Career Point, which is located in Chandigarh sector 34, that is Engineers Career Point. Fine. So you can join the batches, offline and online, both the batches are already started. The dedicated batches are there, so you can join these batches. If you have any query regarding the modules, you can contact to Engineers Career Point. Thank you so much.